Hi, my name is Aijo Kajo, and today I want to solve problem 24 of chapter 12 with you. The problem says, for a galvanic cell as shown below, assume that adding solid does not change the volume of the solution. A. Calculate the potential of the copper electrode and the silver electrode. Is a silver electrode anode or cathode? So we know that we can find the potential with the Nerst equation shown here. So for our copper electrode, the potential will be equal to the standard potential minus 0.059 divided by 2 times log of the reduced, that's the solid, so it's 1, the concentration is 1, over the concentration of the reduced, of the oxidized form, and we have the potential of the copper electrode. We do the same for the silver electrode. The potential equal the standard potential minus 0.059 times log of the reduced form over the oxidized form. So we see that the potential of the silver is greater than the potential of the copper. So the reduction is going to be on the silver electrode. So this one is going to be the cathode. The problem asks if 0.27 gram of KCl is added to the original silver nitrate solution. Calculate the potential of the silver electrode. Is a silver electrode anode or cathode? So we have to find how much Cl minus is added, because we know that the silver will react with the chloride and we're gonna have change of the number of mole of silver in the solution. So the number of mole of Cl minus added is gonna be the mass divided by the molar mass that we have here, and the initial number of mole of silver will be the volume times the concentration of silver. So the number of mole of silver remaining will be equal to the initial minus what will react with the Cl minus. So that's how much silver we're going to have in the solution. So the new concentration will be the number of mole divided by the volume. And now that we have the new concentration of silver, we can find the potential of our electrode. So it's going to be equal of standard potential minus 0.059 times log of the reduced divided by the oxidized. The potential of the silver electrode is still greater than the potential of the copper electrode, so it's still gonna be the cathode. In the third question, it asks if 0.82 gram of KCl is added, what will be the potential? So in order to find the number of mole of Cl minus added, we take the mass divided by the molar weight, and we have the number of mole of Cl added. And if you compare this one, you see that there's more silver added than the initial. There's more chloride added than the initial number of mole of Cl. So the chloride will be in excess. So the number of mole of chloride left in the solution will be equal to the added minus the initial mole of silver. So that's how much Cl we have. So we can find the concentration of Cl in the solution is the number of mole of Cl divided by the volume. And we know that the solubility product of AgCl is 1.8 10 to the minus 10. So from this solubility problem, solubility constant, we can find the concentration of AgCl. So of silver in the solution. So the concentration of silver in the solution will be equal to the Ksp divided by the concentration of Cl. That's this one. So now we can find the new potential at our silver electrode. We use the Nerst equation, standard potential minus 0.059 time log of reduced divided by the oxidized, and we find this value, and this value is smaller than this one. So here the silver electrode will become our anode. That's all. I hope that the video was helpful, and thank you.